Hi everyone, welcome to the Working Group Serving weekly meeting. Today is October 30th, 2024. And we'll be recording this meeting and the video will be uploaded to YouTube afterwards. And we are also following the CNCF Code of Conduct. Okay, let's start with the workstream updates. Jiaxin, you have an update on orchestration?
Yes, I think for the LoRa orchestration, I wrote a controller proposal to support dynamic loading on those base models, and if we have enough time, we can briefly go over the doc in the meeting today. But the overall idea is to provide I think kind of a solution to manage the LoRa in large scale in your clusters, comparing to the static ways. So that's the idea and the doc. Yeah.
Okay,
Feel
yeah,
free to leave comments.
we don't have a lot of open topics today, so we can move it to the open topic and you can talk about it in details.
Yeah, sounds good.
Any update on DIA? I know Sergey is not available today. Is John here? Okay, we can move on. For auto scaling, we are looking at a benchmarking tool, and we are thinking about like creating recurring meetings in 2 different times, and they alternate so that other folks in other time zones can also make it. Ashok, are you here?
Yeah,
Do you want to provide an update on the proposal?
yeah. So we have a sub-project proposal for the benchmarking tool, which is in progress. I'm planning to go over this in the benchmarking sync tomorrow to finalize some of the details, and then share it more broadly next week, probably in this meeting.
Okay. You're gonna go through it at tomorrow's meeting, right? The contributors meeting for benchmarking tool, right?
Yeah.
Okay, sounds good. Yeah, if anyone else is interested, please check out the working group serving calendar and see if you can make it. Otherwise, feel free to catch up with the recording too. Okay, multi-host, Jiaxin.
Sure. Yes. Okay, I can share some updates on the engine side and both VLM as SG-Long. And I already confirmed with the feature owners and the repo maintainers, and people plan to support the PD disaggregation in Q4. And VLM have a draft PR, which is the kind of a slim version. It's different from the traditional, the original one. But this one, I think this PR have some some feature missing. That's the first thing, and it introduced more components like the proxy, which is the local cluster scheduler in splitwise papers. The overall idea is that I think we would like to we also like to spend some time helping to mature the features and make sure. I think on Kubernetes there's a version can be used and test the performance lightweight way without waiting that long to make it work. So that's a goal. I think but the overall I think problem is that in order to support PD disaggregation on Kubernetes, the engine part is definitely a blocker. So that could be some efforts we can make in Q4 to unblock the features. Right. So that's a goal I think on the multi-host side.
Okay. Any comments from others?
Yeah, so this is there's a PR to do one-to-one, right? And then what you're describing here is extending that to different ratios and using a like a KV cache store to communicate between prefill and decode servers. This one,
I think
sure.
yeah. So this one, because the author is from the research team who developed the LM cache, right? So I think their purpose to work on this feature is to kind of adopt their like cache solution. But I think from more like generic ideas, the goal is to provide some KV storage solutions and make that part kind of like standardized. And LM cache they develop could be one of the implementations. And in memory, no matter it's the HBM or DRAM, that could be one of the implementations. And people can bring their own like cache solutions. I think that's a goal, but we would like to spend some time on the like interface standardization, especially the KV cache high-level APIs. I think they already work on the low-level part, and there's also some design problems. For example, in the diagram here, their prefill and decode both generate the first token, which we think that's unnecessary, right? And some like pipelining stuff are not implemented as well. So I think that's the goal. At least make this feature deliver like a workable feature. I think, yeah, by end of Q4. Yeah.
What about the orchestration piece for orchestrating between the code?
Right. That's a good point. I think from our view, like or the platform, I think maintainers will want to make sure the overall new design can be orchestrated by different solutions like the LWS, right? We like to make sure the PD features take the orchestration into the considerations and won't bring new challenges, and orchestration has to adapt later. Yeah, so that's another, I think, goal.
Okay.
Yeah, so beside the VLM SG-long part, I think have the similar plans in Q4. So that's a good news. Yeah.
Thank you.
Okay, thank you for sharing, Justin. Okay, let's continue with our sub-project updates. Callan, do you want to provide an update on Instance Gateway? Callan, are you here?
Yeah. Sorry. Yeah, we're moving right along. We've shared the benchmarking doc there. Gonna look over it internally, but just kind of in implementation process right now. We have a PR out for integration into our endpoint picker or XProc image from our CRD. But yeah, nothing too thrilling this week.
Okay, and this is the new benchmark, right? After the improvement.
This is an ongoing benchmarking doc. Some other teammates have worked on it. I'm gonna take a deep dive on it today.
So a new set of experiments has been added. Like I put that link directly. Yeah, exactly, for the priority aware scheduling. Basically, we discussed before that we have use cases with a target set are considered critical. The ones without are considered sheddable. And so this is a new set of experiments that implements this basic sheddable logic based on criticality of the requests. I was just showing that when we reach a specific load on the servers, we're going to start shedding the non-critical, like the sheddable ones, and that showing that the critical requests will get higher throughput and lower latency. Of course, at the expense of the sheddable requests. So it's basic priority-based routing.
Mm-hmm. Very cool. Thanks. Any comments on that? Okay, serving catalog. Jason, are you here to give an update?
Yeah. No major updates this past week besides this HPA stub PR got merged. So thanks to the work and feedback everyone gave on this.
This is only for like the core folder, right?
Yeah.
Yeah, because we've been discussing like the case of part as well. And those are like everything, including the HPA, is kind of hidden from the case of inference service spec. So we need to like continue discussing like what parts needs to be exposed as part of the serving catalog. Yeah, something to discuss later. Okay, open topics. I have one item here. So since we have KubeCon in 1.5 weeks, I suggest that we cancel the meetings during that KubeCon week. Any objections to that? Okay. Yeah, and we do have a working group serving talk by me and Eduardo. So if you have anything that you'd like to be highlighted in our slides, please send us a message, and we'll take a look. And hopefully we can present the work that this working group is doing very well. But feel free to add anything and provide feedback before and after the talk. And there are also 5 other talks on Kserve and perhaps other like serving frameworks. I only did a quick search on Kserve, so feel free to attend if you are interested. If you see any other talks related to serving, please add it here so that other people can also attend.
There's a talk. It's not so much about serving, it's about Envoy Gateway and its extensibility, but we are showcasing the LLM Instance Gateway as basically an example of such an extension. So I provided the link in the chat.
Thanks.
Yeah,
can you add it here?
I can't. I don't have write permission to the doc.
Okay.
Yeah, so Kellen helped out, and
okay.
yeah.
Let me see. Are you in the working group serving mailing list?
I am not.
Okay, then you should be able to add it, unless maybe you're using a different account. So you might want to check that.
Okay, I'll check it for sure.
Yeah, feel free to add if anyone has other talks that you'd like this working group to know. And it would be great to meet in person. Okay. Jiaxin, do you want to talk about this proposal in more detail?
Yeah, sure. Let me share this screen.
You should be able to share.
Okay. Okay. Right. Yeah, I think firstly, we start the work around like I think Q2, and in Q2 we found there's a few like problems managing like LoRa's in large scale clusters, and there's few problems, right? And there's we cannot dynamically load and unload like LoRa models on top of base models, And the LoRa information, because from user's perspective, we always talk to models, and I think the OpenAI compatible API is pretty like standardized, and LoRa itself is a model, but on the physical deployment side, LoRa information is not exposed to Kubernetes. So that's a big problem, and engine operate as a kind of a black box to the resource managers, and make everything like the service discovery, load balancing, and like cold start problems really hard to support. And right, and the engine side, I think it also cannot provide some isolations, because LoRa computation does leverage the base models computation, right? And different LoRa's hosting on the same pod, it actually introduced interference issues, and I think that's a big problem, like affecting the adoption on the multi-LoRa inference, and further like affect the adoption of the fine-tune services, because if we like to reduce the resources on the fine-tune, we ask the users to use the LoRa, use the LoRa way to do the fine-tuning. But if the ways is, I think, not if the LoRa inference performance is not promising, then there's no it's meaningless to ask users to do the LoRa-based fine-tuning. And the last part, I think most of the work previous 1, 2, 3 work are done on the engine side. There's no like solutions on the resource manager side on the LoRa management. So at that time, I think we wrote a RFC in the VLM community to address those issues, and yeah, there's a link. And most of the I think I would say like low-hanging fruits has been resolved, and this talk is primarily talk about the system level designs, more on the Kubernetes side. Yeah. So the high level designs to build some orchestrations for LoRa's, and I want to note here is so the service discovery part and like the traffic part. So the below doc just shows the alternative design, because the community already proposed the instance gateway project, right? I think at that time when we work on it, we haven't built up the project yet. So we adopt the Kubernetes native service for the service discovery and the traffic management. So technically, I think we should move to the instance gateway for the data plane traffics. So the below docs are copy based from an internal doc, so we haven't got enough time to adapt to the new gateway project yet. I think at that time we think the Kubernetes service is the abstraction for every LoRa models. That means for base model, every base model deployment has a Kubernetes service, and every LoRa deserve a Kubernetes service at the entry point. But the tricky part is the Kubernetes service user labels, right? And the LoRa can be deployed on the base models, and it's hard to distinguish the LoRa's and the base if we use the service. So here we plan to use the manually control the endpoint and work with the service kind of a headless way. So for the orchestration part, I think we have two options in mind. The first is the just provide the controller, and there's no need to build the CRDs, because this is a kind of lightweight. And for example, if I make some changes to the pod annotations, like I add the LoRa list, so the controller should watch for the custom controller should watch for the pod, and it can create the necessary endpoint and service to manage the routing side, and also do the LoRa loading. So this is kind of like lightweight, but the tricky part is we found it's hard to manage the LoRa status because if there's something happens in the middle, it's very hard to control. And yes, that's the kind of a lightweight solution. And then we move to the CRD solution. So CRD solution introduces a CR object, and once user create the CR object, the LoRa controller actually watches change. And firstly, it goes to the LoRa scheduler and try to find the best fit pod, and then send the command to the pod container to register this LoRa. At the same time, it creates the necessary, I think, objects for the routing purpose. I think initially we load the model. We talk to the engine directly, but in later versions we move to the sidecar and use the sidecar to build to hide the complexity to talk to the engine pod. Yes, that will be like 100% Kubernetes like native way, right? And because of the CRD, there's a lot of like state information we can manage on the LoRa object itself. I think we can just briefly go through the LoRa specs, and we have the design have like two, I think, specs to indicate the relationship between like LoRa's and the LoRa adapters and the base model, and either one can be used. The base model is reserved for like I think we internally are not using this one at this moment. And still use the pod selector because this is more like flexible, because it doesn't necessarily need to be one like deployment. And the base model was created for the like higher level abstraction objects, and there's a scheduler to decide the behavior of the LoRa scheduling, and artifact URL indicates the LoRa's locations, including like different storage options like S3 GCS or Hugging Face. And the rank size is being used to for the scheduling to choose the best fit pod. This is actually one of the like scheduling policies. And dynamic merge is like experiment features, and we'll talk about it later. It's more like advanced like features. And the last one is replicas, and because there's I think the best practice is on one pod we deploy at most like one LoRa's, because LoRa can do the batching, request the batching. There's no need to deploy more. So if the traffic we cannot handle the traffic on one pod, we have to span to other pods. So we need the replicas. So this one, that's just the additional information we plan to inject. Yeah. So probably not a good design because we can still use the like the annotations. Yeah, I'll skip the rest of the part. That's just traditional views. I think the overflow is pretty straightforward as we go through already go through the CRDs. So user create a CR, and the controller watch the CR object and update the status, and then it talk to the LoRa scheduler to find the pod. And once the pod get returned, it update the CR status, and then it do the loading. And once the loading is done, it update the CR again, and after all the loadings finished, and they create the rest of the manage the resources, and until last step, they just update the LoRa to ready, and yeah, so that's a process. I think because the LoRa deployment is very close to like pod deployment, right? So the overall process is a little bit similar to the scheduling, the pod scheduling, and some part of the kubelet life cycles. Yeah, so there's some components needed. The first is the LoRa downloading part, and it depends on the engine. So different engine has different support. So if let's use the VLM as an example. VLM originally support like abstract path. It has to be POSIX interface, and we add a change to support the dynamic loading from the Hugging Face. Downloading from the Hugging Face. And yeah, so in order to support like more, I think object storage, we need to add the support on the engine side. That's one option. The second option is right now we use the sidecar to delegate the model downloading, because that's much easier to change, and is also easier to manage on our side without modifying the engine, right? So we can ask the sidecar to download all the LoRa artifacts, and then intercept the request, and pass the like the abstract absolute path to the engine side for injection. Yeah, so that's the artifact management part. And the LoRa scheduler part, I think the interface is pretty clean, and right now, I think we developed a few ones like the list adapter, list rank size, and the list traffic. Yeah, based on different scenarios, I think they have different performance numbers, but we haven't showing any big differences between these. We haven't done the benchmark yet. Right, because the best practice is to always use one scheduler policy in one model. So in that case, I think there's no like scheduling conflicts. It's similar like Kubernetes schedulers. We usually leverage one scheduler to manage all the pods in one cluster, right? And the rest of the part, I think the major features on the multi-replicas, rebalancing, and auto scaling. I think we haven't support like in the POC version, we haven't support the auto scaling and the rebalancing yet. Rebalancing, we do have the consideration for the like ILP based rebalancing, but the LoRa is kind of lightweight. So the auto scaling is not that important from our perspective or point of view. Because if we don't use it, then it's just it depends on the rank size, right? Some of the LoRa's are pretty small, like rank 8. There's no need to manually, I think, unload the LoRa. We can wait for we can just let it go. If there's more traffic on the other pod, it will trigger the preemption, so the LoRa will be offloaded. So technically, the auto scaling is not that important in these areas. Yeah, so that's a primary reason I think the auto scaling is not implemented yet, and it also brings some complexity. Oh, sorry, Abdullah, I think I just see your hands.
Yeah, while we're on the topic, so in the API above, you're deciding the number of backends or pods that will support a specific adapter, right? And then
yes,
for that number, you're going to ask the scheduler to decide which pods should load that adapter, right?
Yes.
Or should serve it, and you're controlling the serving by manipulating the endpoint slice object. Now, how do I, like you're saying auto scaling is not important. I'm just confused here, because if you get more traffic to that adapter, I'm assuming that this resource, like the LoRa LoRa spec, does it have a scale sub resource that you connected with HPA to increase the number of replicas or decrease them, or you don't care at all? Like you have a static value here and that's it. Like,
That's a static value.
Okay.
At this moment, it's a static value in the initial design. Yeah.
But why were you saying like auto scaling here is not important? I'm slightly confused here. Like, if you get more traffic, wouldn't you want naturally to have this adapter available on more replicas? How would you handle it?
Yeah. So I think the there's the workaround. I won't say it's I think in the most of the cases it's not that important. And let me see. I think I write somewhere. So the key thing is if you think the LoRa have more traffic, just use a larger replica set at the beginning, and so in that case, I think a few like a few base pod will load the LoRa, because the LoRa number of the LoRa's the maximum count is equal to the size of the backend pool, right? In that case, I think that's the largest scale it can support, and yeah. So the the downscaling is not that important, because if we don't use it, because it doesn't withhold any GPU resources, right? It's different like the pod, yeah.
Right, and so you're not using this also to sort of limit a specific adapter to a specific amount of resources, in case like you get, like, for example, I'm thinking about the case where you have two adapters. One is production, one is like, it's also production, maybe that has a lower priority. You're not trying to use this mechanism to say, oh, this adapter should get more resources than the other adapter. You're not trying to implement priority here with this, because at the limit, like, I can see like people say, okay, I don't know how much traffic I'm going to get, and so I'm always going to set the replica size to the maximum for every single adapter, and you're ending up basically loading all adapters everywhere. What this allows you to do is to basically have a mechanism to limit, basically set like a lower limit for specific cases, but not necessarily control too much, have a lot of control over like how much resources each adapter gets. It's only one way, right? Like I can limit how much resources I want to give to a specific adapter, but not necessarily how I'm going to dynamically react to traffic.
Right. Right. I think to me that's a different problem, and we think that's an isolation problem. Right. How much resources each LoRa can use, and we distinguish this with the auto scaling problem. And so there's a background I think I need to share is we do have some process to do the rebalancing. Actually, we don't need the auto scaling, but that part, I think they just take all the inputs and calculate the new like placement plan, like using ILP, and that plays part of the role as the auto scaling. I think I should make it more like clear here. We think the is a little bit different from the pod and the HPA. So that's probably too heavy for the LoRa cases. We don't want to make the system very complex and introduce separate logics. So the rebalancing work kind of plays part of the role of the auto scaling. Yeah.
Okay, so you're not trying to also here with this approach collocate adapters, like a specific set of adapters are always collocated in the same set of pods, so that you route traffic to those adapters and ensure that you don't have a lot of switching. Like, basically you want to make sure that each back end is not doing a lot of loading and unloading of adapters between CPU and GPU. You still think that this is like an inference gateway problem, not a problem that you want to solve through this scheduling technique?
I don't think. I think for this, I mean the multi-replica and the auto-scaling feature itself, it should not cover this part because that's not their goal, right? When you do the auto-scaling, you don't care about the how many and if it can be scheduled, then you don't care about the interference problems there, right? So that's more like a scheduler problem, or the like other problems are like isolation problems, I think. And even the gateway should not like take care of that problem. And because I think the responsibility is it knows the endpoints and just distribute the traffic like evenly or based on some right routing algorithms. So that's a key side. We don't want like the gateway. Okay, you have a like full endpoints, right? You see 10 LoRa's and you detect the traffic and then like probably like send the traffic to the partial view of the entire like bank pool. That makes the like system complex. I think it's still the problem of the scheduler and like the isolation. Yeah.
I mean, with LoRa affinity-based routing, the side effect is that we're going like for specific pods are going to always load specific adapters and have specific adapters active at each moment. At least that's what we're observing. Like when we route traffic in the instance gateway and say, okay, you get the list of adapters available on each active, specifically active. I'm talking about like active, like basically loaded into the GPU. And we only route the request to those active adapters, of course, like active adapters, active replicas. The side effect is collocation of
right.
Okay.
Yeah. Let's move forward and
Same
talk
side,
about those
Justin.
offline.
We have 2 more hands raised.
Oh, okay. Yeah.
So Apurva, you're first.
Yeah. Hey, Jackson. I'm trying to wrap my head around this a little bit. So, does this assume like standalone deployment of VLLM, or does it also take into account VLLM being orchestrated by something like Racer, for example?
Yeah. So technically, I think because the orchestration part, the association part is pretty flexible. It can just use the pulse selectors, and the REST process relies on the features of the engines. So technically, like a case of I think there's one more challenge because the endpoint is protected by the ISQ, right? Yeah, if the network is accessible, and then it technically should be transparent and should work with the like K-server-based solutions. Yeah.
Okay. And then K-serve or Racer, they would be auto scaling the VLLM pods, right?
Right.
So then how does the auto selection mechanism work?
Yeah, so the workflow is K-serve deploy the serve endpoints, and it probably bring up a few like VM pods, and the LoRa controller will find the select like you leverage the selectors, the pod selectors, and find those VM pods, and it will talk to the pod directly to execute the load and unload operations. And the other thing is, I think, there's one other problem is the service discovery, and I think currently it is not handled like compatible because the LoRa, the proposed LoRa controller here, it create the service. It create a few things. Could be like one option is the service plus endpoint combinations, right? The second thing is in future we plan to support the LLM gateway, like LLM route object, right? In the case of already, I think already orchestrate the discovery part. I think that could be a conflict. Yeah, but technically, I'm still thinking it can be resolved. But that's a little bit weird because the LoRa traffic will go through the separate like route, but the Kaiser part, yeah. So the I think that can be that need to be I think coordinated. Yeah. True. Yeah, the routing part is a problem. The orchestration or scheduling itself is not a problem at this moment. Yeah.
Gotcha. Yeah. Okay. Great talk. Thank you for this.
The
Hey,
next
Fei,
one is
I think.
Fei, who has his hands up.
Can you hear me?
Yes,
Okay.
I can hear you.
Okay. Cool. We need a solution to deal with LoRa. So I just have a few clarification questions. So you were mentioning the LoRa adapters is going to manage it as a sidecar container of the pod, right?
Oh, so the sidecar is the kind of like a downloader. I think that's just a like kind of alternative design. So if the engine itself can download the models, for example, we pass the Hugging Face endpoint. So right now, like VLM already support to download the LoRa's from Hugging Face, but if it's some other like object storage, and people do not like to rely on the engine to do the artifact management. I mean, the option 2, the alternative design is just send the like dedicate the request to a runtime like proxy, and the proxy can download the artifacts and then execute the load LoRa command, send this command to the engine side. Yeah, so then the sidecar plays the role of the artifact management and the loading request. Yeah, so that's
okay.
part. Yeah.
So that /add LoRa endpoint is going to be provided by this sidecar? Am I correct?
Sorry, could you repeat the question?
So I think in the workflow you said once you have a new LoRa, you are going to send a /add LoRa to make that call, right? So who is serving this? Is a VM container or the sidecar?
Actually, I think in so for the simplified version, so the LoRa controller can send the command to the VLM pod directly without the sidecar. So I'm talking about the alternative design because in our like versions we do introduce the sidecar, and it is a proxy to those like LoRa management like admin commands to the like engine pod. But technically it can in the diagram here it can talk to the VM container directly without interacting with the sidecar. That's a simplified version. Yeah.
Okay, cool. So the last question is so you described the workflow from adding, so that makes perfect sense. But how about the removing? So are you going to what is your consideration for removing some LoRa adapters from the pod? So because analog to pod to nodes is like many times people just delete the pods, right? So do we supposed to delete the CR or just changing the scheduler? I mean, constraint of the CR to make that happen?
Yeah, that's the good question. I think there's in the POC version we have two I think two parts handling the unload. The first is we add the finalizers to the objects and make sure it tries to unload the LoRa first as a like a best effort. And the second part is whenever a pod is have some like issues, we also like try to unload the LoRa. Yeah, so I think the unloading part just happening on this like the error handling side, and finalizer part. Yeah.
Okay, fine. Okay, actually, sorry, two more questions. Last one. So if PARS is restarted, so do you need to do anything else to reload those LoRa, or is it going to automatically pick up the LoRa's?
So the LoRa controller will. Oh, sorry. I think I didn't introduce that part. Yeah. So there's a instance list, and yeah. So if it will maintain the active PARS, like the LoRa has been scheduled to. Yeah.
Okay, cool. Thanks.
Okay. Yeah, let me finish the last part. And we think there's two important research topics. The first is dynamic merge. Actually, the last year, I think last end of the year, both Punica and LoRa solved the problems to batch schedule the LoRa request, right? But the problem we observe at this moment is merge the LoRa interface does introduce the extra computing overhead. So the first one is from the OSDI DLoRa papers. It is a little bit slow, and we did some benchmark and do observe the patterns. So the yellow the green line and blue line, the blue line is the merged LoRa, and the the green line is the unmerged single LoRa. I think it has the close to 20% to even 40% in different scenarios. The introduce that many overhead. So the key problem is when we use it in production, if the traffic is very large, then it's not worth using LoRa. It's better to merge the LoRa as a single instance or single model. So in that case, it can achieve lower latency and better throughput. I think OSDI DLoRa paper talk about some dynamic merge proposals, but I think they deeply built into their system, and I think the next phase we are looking for more feasibility to support in industry project, and yeah, see how much we can gain from such features. And the second research-related topics is isolation. I think we already talked about it, and different LoRa's on the pod actually introduce the interference. The major problem is the computational resources. I think are shared among the single pod, right? But right now, I think we break the design of the Kubernetes. We deploy multiple LoRa's and the base models in one pod. So in that case, every model shares the same engine, and that engine hold all the GPU resources or CPU memory resources. How can we build effective isolation solutions? So that's the next steps goal. I think we have some research work on this path. Yeah, we like to share more details in near future soon. Yeah. Yeah, so that's the overall update on the LoRa side. Yeah. Any questions? Tenjin, go ahead, please.
For the merged LoRa, how is, I'm curious about that. Doesn't it need a rollout of the base model and also? Do you not have to roll out the whole binary again, or I guess you have to load the model again into the server, right?
I think there's a different approach, and technically it can bring down instance, and after the merging it can bring it up. And there's also some work on the PFT to support the logins in more I would say a seamless way. So I think when we bring back to the industry project, I think those are all different options, because sometimes the research papers chase for more SOTA solutions, but practically it might be not the good ones. So I think this is the still open questions. I don't have a clear answer yet. Yeah. And another challenge we do notice is actually two challenges. The first challenge is when we do the dynamic merge or unmerge, it changed the way we sell the GPU resources, right? In LoRa, we share the resources. We probably sell some quota. If it becomes the unmerged instance, which consume the entire GPU, so the way we sell the resources change a little bit. That affects the product definition. So that's the first challenge. The second challenge is we do see some of the techniques probably break the best practice of the Kubernetes designs, because all the composed containers are immutable. It's not that easy to orchestrate such dynamic workloads. Yeah. Okay, Kevin.
Yeah. I was just curious. Speaking of merging adapters, I know that that's just a simple addition into the base model, but I was curious if you've looked at merging other adapters together. So let's assume you've merged an adapter into your base model. Can you take that merged adapter's inverse and apply that to a separate adapter so that it would kind of work with this new merged base model?
Mm.
I think the logic should apply, but I've never tried it.
So from I think real world practice, we have to leverage the metadata or lineage informations to do the reverse way. So once we merge the interface, we cannot say, okay, we do extraction and we can get the base directly. So that's currently, as I know, that's not working. The way we can do is we based on the metadata. We know where the base model come from. Where is it from? Which LoRa plus the base, and based on the existing artifacts and the metadata tracking information, so we can do the physical mapping. So that's I think very obvious way. But if there's a more advanced way to do it, we have to explore in the PFT some ongoing work. Yeah, the parameter efficient fine tuning library. Yeah.
Cool. That's all I had. Thank you.
Yep. Okay. Hey, I think we have. I'm down here. Yeah.
Okay. Thanks, Josh. I think it will be useful to also figure out how to adapt to the existing projects, like the instance gateway, since you mentioned you didn't have time to adapt to that yet. So that would be a good thing to do and give the community more time to review the proposal.
Sure. Yes, that sounds good. I'll make necessary changes to address that feedback. Yeah.
Thanks. All right, that's it for today then. Anything else? All right, we are on time. Have a good day, everyone.
Thank you.